Welcome to this explainer. Okay, if you've ever felt completely overwhelmed by massive, chaotic spreadsheets, or if you've just really wanted to uncover those hidden stories buried deep within your data, you are absolutely in the right place. Today, we're unlocking the foundational building blocks to some true data superpowers, and we're doing it through R programming. Now, R isn't just another random piece of software. It is arguably the defining language of data science. It's a tool that's specifically designed to make your work with data more productive, highly interactive, and honestly, incredibly effective.
To really set the stage here, there's a quote I absolutely love that perfectly captures the spirit of what we're about to dive into. A well-known R user, Simon Blomberg, famously said, "This is R. There is no if only how." I mean, how empowering is that? It's basically the Yoda philosophy applied directly to data analysis. Because R is entirely open source and has this massive, super supportive global community behind it, it removes all those usual roadblocks. It makes nearly anything possible when you're trying to extract actual meaning from raw numbers.
And get this, when you ask professional data mining experts what software they actually use most often in their day-to-day work, R consistently comes in first. In one specific survey data set, it was actually 50% more popular than Python. Now, don't get me wrong, both are absolutely crucial, major tools in the data science world, but this really validates why learning R is the perfect starting point. Oh, and the best part? Unlike those corporate software packages that can cost literally thousands of dollars a year, R is completely 100% free.
All right, here is our roadmap for today. First, we'll cover the language of data science. Second, setting up your toolkit. Third, data types and structures. Fourth, importing data with superpowers. Fifth, visualizations and summary statistics. And finally, modeling and dimensionality reduction. Let's get right into it.
Kicking things off with sections 1 and 2, the language of data science, and setting up your toolkit.
So, how is this software actually structured? Well, think of the base R software as the engine of a car. It handles all the raw computations and does all the heavy mathematical lifting completely behind the scenes. But, you wouldn't just stare at a bare engine block while you drive down the highway, right? That is exactly where RStudio comes in. RStudio is your dashboard. It sits directly on top of the R engine and provides this beautifully unified, organized interface. It just makes interacting with the language so much easier, gives it consistent keyboard commands, and honestly makes the whole process a lot more fun.
Getting this whole foundation set up is incredibly quick. It's basically a simple 1, 2, 3 process. Step 1, you just head over to the Comprehensive R Archive Network, usually just called CRAN, and download the base R software for your specific operating system. Step 2, you visit rstudio.com and grab the free RStudio desktop version. And step 3, you simply launch RStudio. Moving forward, you'll pretty much never open the bare base R application directly again. You're going to do all your amazing work right from that organized RStudio dashboard.
Moving right along to Section 3, Data Types and Structures.
Okay, so how does R actually hold your data? Let's walk up the hierarchy of these structures. We start at the very baseline with a vector. That's just a one-dimensional line of data where everything is the exact same type, like a simple list of numbers. Step that up to 2 dimensions and you've got a matrix. But the absolute rock star of the show, the one you are going to use constantly, is the data frame. It's 2-dimensional, but it allows for mixed data types. You can really just think of it as the closest thing R has to a standard spreadsheet. It represents the ultimate, optimal level of complexity for your everyday data analysis.
Which brings us to the really fun stuff. Section 4, importing data with superpowers. The crucial thing to understand here is that while the base R software is fantastic, its truly limitless potential comes from third-party add-ons. These are called packages. Packages are basically bundles of contributed code written by the global community, and they add brand new functions to R. There are over 9,000 of these available right now. Downloading and loading these packages is literally what grants you those analytical superpowers, letting you accomplish highly specialized tasks that would otherwise be either totally impossible or just incredibly tedious to code from scratch.
But, as you might guess, managing all those amazing add-ons can get a little tricky. Enter Pacman. It stands for Package Manager, and I honestly like to view it as the one package to load them all. Normally, installing and loading different tools requires this clunky, multi-step routine, but the Pacman tool, it handles downloading, installing, and loading any other package you could possibly need with just a single elegant command. It makes your workflow so smooth.
So why do we need these package superpowers right out of the gate? Well, frankly, importing data using the built-in, old-fashioned base R methods can be exceptionally frustrating. It's messy. You often have to specify exact delimiters manually. If your spreadsheet happens to have missing headers or just a few empty cells, the base import can throw a massive error and completely fail on you. Plus, you have to memorize these complex, clunky commands like read.table and tell it exactly how your file is separated. Honestly, nobody wants to deal with that.
So let's upgrade our toolkit. We use a package called Rio, short for rimport/output. It completely eliminates all of those import headaches. With Rio, you have an elegant, one-stop solution. You literally just type one simple command, import. That is it. It automatically recognizes if your file is a CSV, a simple text file, or an Excel spreadsheet, and it seamlessly reads it perfectly into a data frame without you having to write any complex code. It's a real game changer.
All right, Section 5, Visualizations and Summary Statistics. Getting a visual impression of your data should always be your very first analytical step, and R makes this beautifully simple with its default plot command. What's absolutely amazing about this command is that it's incredibly smart and adaptive. If you feed it categorical data, it just automatically knows to create a bar chart. Give it a mix of categories and quantitative numbers, it smartly generates a box plot. Feed it a pair of quantitative variables and boom, it instantly creates a scatter plot. It just adapts its output perfectly to whatever data type you hand it.
Now, when we start talking about overlaid plots, where we stack multiple graphical views on top of one another, there's definitely a right and a wrong way to do it. Think of art history. On one hand, you have Picasso and Cubism. The goal there is high information density. You're providing complementary perspectives that support one another to add real insight. On the other hand, you have Hieronymus Bosch. That is pure, chaotic information overload that simply makes the viewer's brain shut down. When you're using R to overlay, say, density curves onto a simple histogram, always be a Picasso. Use restraint and add layers that clarify the data rather than confuse the viewer.
And finally, Section 6, Modeling and Dimensionality Reduction.
Let's start this off with hierarchical clustering. This is a fascinating procedure where R groups your observations based on the principle of like with like. Imagine feeding R a data set of 1974 sports cars, right? You've got tons of different variables, weight, horsepower, engine displacement. Well, R objectively measures the mathematical distance between every single car and builds what's called a dendrogram. It's basically a visual tree. It shows you exactly which cars naturally group together based on those shared traits. It finds regularities that would literally take us humans weeks to sort out manually.
Now, to understand our next technique, Principal Component Analysis, or PCA, let's use a quick analogy. PCA is all about dimensionality reduction. Imagine trying to analyze the complex, multivariable reality of 3D people walking around a room. It's just too much chaotic information to process all at once. But if you look at their 2D shadows from above, you flatten the reality, yet you still retain the most critical information: how tall they are, what they're wearing, how they're moving. PCA does this exact thing to complex data sets. Less noise translates directly into more meaning.
And here's exactly how R pulls off this shadow trick, both visually and mathematically. First, it draws a regression line straight through the center of your scattered data points. Second, it measures the perpendicular distance from every single point back to that line. Third, it collapses, or slides, those data points down onto the line, effectively turning them into those flattened shadows we just talked about. And finally, it rotates that line to give you a clean, simplified component. It completely demystifies complex data down to its absolute most meaningful essence.
Well, we've covered the language, the structured workspace, the data types, those amazing package superpowers, the adaptive visuals, and the modeling. You now possess the true foundational building blocks to make sense of almost any data set you might encounter. So, the final provocative thought I want to leave you with today is this. With the limitless superpowers of R now completely at your fingertips, what hidden stories are waiting to be uncovered in your messy data? Go download RStudio and start finding out.